Okay, so as we continue our discussion on confidence intervals, we're going to talk a little bit more about interpreting them. Okay, so it says for every random sample that can be taken from a population, there corresponds a 95% confidence interval. 95% of these confidence intervals will successfully contain the population proportion and 5% will not. If I change my confidence level, like if I change this to 90%, okay, then what will happen is 90% of the confidence intervals will successfully contain the population proportion and 10% won't. So there's somewhat of a trade-off here when you increase or decrease this value, and we'll see what happens also when you do that, what happens to the width of the confidence intervals. Okay, in most cases we don't know if the interval contains the population proportion, kind of what happened back with our M&M problem. The proportion that we got in our sample of 100 M&Ms when we built our interval, the population proportion that someone on a website claimed were yellow was not in our interval. Okay, and because if you actually knew the population proportion, why would you sample? Okay, so let's look again at computing another confidence interval. So we picked 500 random people and we surveyed them and found that 72 were smokers. So we want to find the 95% confidence interval. Okay, so first I'm going to calculate my p-hat. Okay, so my sample proportion, which will be the 72 out of the 500, and that gives me 14.4%. Okay, now I can use the central limit theorem because I have over 10 that were smokers and I'm going to have over 10 that were non-smokers. If you take the 500 times the 72, okay, so my sample is large, my population's large because we're talking about probably everybody. Okay, so and I have a large population, a large sample, and they were randomly selected. So we're good on the central limit theorem. Okay, so I also need to calculate my standard error, and again this is going to be an estimate because I have to use p-hat to find my standard error. I can't use p, okay, because I don't know p or I wouldn't have taken the sample. Okay, so just plug in p-hat for each of these values. I get 0.0157 or about 1.57%. Okay, so my margin of error, since we're doing a 95% confidence interval, is 1.96 times this standard error. Okay. Last time, on the last couple examples, I actually wrote everything into the formula first. So this one I'm doing just a little bit different. I calculated kind of everything separately as I went through. So I calculated the standard error and I multiplied that by my z, what we called the z-star, how far I need to go from the center to capture 95% of the sample proportions. Okay, so that's that 1.96. Okay, so now I can take the 0.144 minus the 0.031, my margin of error. That gives me about 11.3%, and the top value is about 17.5%. Okay, so how do I write my conclusion? It says we are 95% confident that between 11.3% and 17.5% of all people are smokers. So let's look at some confidence versus margin of error. Okay, so if your sample proportion, let's say, is 50%, okay, now some of this depends on how large your sample size is, but if you want to, in this case we're using, it looks like a 0.1 as a standard deviation or standard error. So if I want to get 68%, I go one standard deviation on each side. Okay, 95%, I go 1.96 or about 2, right? 99.7%, I'm about 3. But you notice how these these lines are getting longer, because if you want to include more of the samples that actually include the population proportion, you need to include more along the number line here. So if you're going to increase your confidence level, it's going to make your interval wider as you do that. So it's kind of a trade-off. But a lot of times it doesn't do you any good to have this really narrow interval to say, oh, I know my population is between, and use two numbers very close to each other. Sounds good, but you're only 68% you're only 68% confident that it's in there. Okay, so there's somewhat of a trade-off between, if I increase my margin of error, if I increase my confidence level, that's going to increase my margin of error and make my interval wider. Okay, so this is what I just said. Increasing the level of confidence increases the margin of error, and decreasing the level of confidence decreases the margin of error. Okay, so it's a trade-off in terms of you want higher confidence, well, you have to have a larger interval. Okay, so this time let's do the 90% confidence interval for that same problem. Okay, again, calculate p hat. Okay, my standard error, you notice this part doesn't change. The only thing that changes is this piece right here. And in the other video I showed you how to find the 1.645. Okay, so and fit 90% confidence interval, the multiplier, your z star value is this 1.645, multiply it by your standard error. Now I have a 0.026 margin of error, and if I go back a couple slides, remember that, so it's about 2.6%, compare that to this one, which was 3.1%. So you notice in this problem with the 95% confidence interval, I have a larger margin of error. That's because I have to include more of the sample proportions. Okay, so again, I increased if I increase from 90 to 95%, increase my confidence level, it makes my interval wider, or you end up with a larger margin of error. Okay, so let's finish this problem. Okay, so again, I'm going to subtract my margin of error from my sample proportion, and I'm going to add it to my sample proportion. All right, so now we're 90% confident that between 11.8% and 17% of all people are smokers. And because I have a smaller confidence level here, I have a skinnier interval, okay, than I did back when we did the 95% confidence interval. So just to kind of show you what happens when you change your confidence level, how that changed the interval. Okay, so let's look at another one. 176 of 200 patients randomly selected to receive treatment survived. Okay, so we want to find the 90% confidence interval. Same idea, we're going to calculate my sample proportion. Okay, and again, you kind of should check those things. I have a large, sometimes it's hard to tell if you have a large population because you're not exactly sure what the population is, but they randomly selected 200 patients. It sounds like it's a fairly large population. I have over 10 that survived, and I have over 10 that died, right? If you take 200 minus 176. Okay, so I have a large sample, they're selected randomly, and I have a large population. Okay, calculate my standard error. Again, I'm using the p hat, so it's just an estimate of the standard error. I get 0.023. Okay, since I'm doing 90%, I'm going to multiply that by the 1.645. This is the number that changes based on your confidence level. If it's a 95%, I would have been using 1.96 here. Since it's 90%, I use 1.645, and then I add and subtract, okay, to this population proportion. I'm sorry, to the sample proportion. We don't know the population proportion. Okay, so now I can say we're 90% confident that between 84.2% and 91.8% of all people who received the treatment survived. Okay, so a lot of times they actually do this in experiments, so they actually can come up with some type of interval of your chances of living idea when you have a certain treatment done. Okay, so another way you can use confidence interval is we can look at 300 randomly chosen voters and see if they favor a bond initiative to fund a new college sports arena. Okay, we find out that 120 did support it out of the 300. And if you would go through the math and do the confidence interval, you should come up with between 34% and 46% would support it. So just based on these values, it actually probably will not pass because you need a 50% to actually pass it. One thing you have to watch when we talk about voting and doing intervals is the interval is actually really only good for about the instant that you actually did your sampling. Okay, especially with like political candidates and stuff. What happens is something might happen in the news, and it's really easy for someone to change their mind of what they, who they're going to vote for or how they're going to vote for on a certain issue. Okay, so a lot of the political polls, when they do them, you can't extend them for any long periods of time just because people's mind changes before the actual voting occurs. Okay, so that's just one thing to pay attention to. If you come up with a poll that was way off, it very well may be way off just because it was done very early in the election versus right before the election. And that's a lot of times why they use exit polls to try to determine who's going to win certain states and stuff. Okay. Yes, they do a lot of polling beforehand, especially in years for presidential elections and stuff. Okay. But you have a lot of those undecided voters, or someone who says, well, I think I'm going to vote for this person, and then they don't. Or they have a little bit of an issue of they think they're going to vote for someone, and then they actually don't even make it out to vote. So I forgot what I was talking about because I got interrupted with a phone call, which is kind of interesting as I make these movies. But anyway, okay, so I think we were talking about voting and stuff. So I think I mostly passed on my little bit of tidbits about polling and voting. Okay, so just a little summary here. Okay, we can use confidence intervals to get a possible value, or possible bound. Actually, it's not even just a value, it's just a bound on a population proportion. Okay, and again, you have to make sure you have a large enough sample, so you have at least 10 successes and 10 failures. We're normally going to use 95%. If you want a smaller margin of error, you can lower your confidence level. Okay, or if you want to have a higher confidence level, you end up with a wider interval or a higher margin of error. And don't remember, it's not that there's a 95% chance that the population proportion is in the confidence interval. It's just we're 95% confident that the process we used, right, will contain the proportion, the population proportion. Okay, and then you should look through the case studies if you ever have issues with trying to solve the problems.